So finding the inverse of a function is actually a relatively easy procedure if you remember some basic algebraic expressions and simplifications that we've been getting ourselves used to for a long time. Basically, the process involves the following. Number one, if we're given a function f of x, rewriting it as an equation in terms of x and y, switching the values of x and y in the equation, the variables, and then isolating y in the new equation. And then we're going to rewrite that new expression in terms of f inverse of x instead. So let's start right here. Let's say I've got f of x is equal to 1/3 x minus 6. How do I find the inverse? Well, step number one, I'm just going to go ahead and write my function in terms of y is equal to 1/3 x minus 6. It is a one-to-one function. I know there's an inverse right here. Let's see what happens. If I have y equals 1/3 x, so I'm going to switch x and y by step number two, right? So x is equal to 1/3 of y minus 6. So the next step is to isolate y. In this case, we're solving for y in the equation by adding 6 to both sides. So I would tell you x plus 6 is equal to 1/3 times y. And if I want to get rid of that 1/3 that's next to the y to completely isolate y, I'd have to multiply both sides by 3. So 3 times the quantity x plus 6 would equal 3 times 1/3 y. And we know what's going to happen right there. The 3 and the 1/3 are multiplicative reciprocal, are multiplicative inverses. That is the reciprocal, so they'll just cancel. And we're going to be left with y is equal to 3x plus 18. So using our appropriate notation, we're going to say that the inverse function, f inverse of x, is equal to 3x plus 18 in this particular case. Very simple process. Let's try another one. All right. It seems we need to find g inverse of x here, right? We're actually looking for finding g inverse of x. Only this time we've got a little bit of a different kettle of fish, shall we say. Y is equal to x minus 1 over x is our original function. And the steps that are called for to solving for this inverse function, recall means that we have to switch x and y. So x has to equal y minus 1 over y. Okay, what do we do now? Well, if we want to isolate y, that means that we're going to have to get any y values out from the denominator, which means we're going to have to get rid of our fraction by multiplying both sides by y. So I'm going to get xy will equal y minus 1 when I multiply both sides by the LCD of y in this case. And if I want to isolate y terms in this function, that means that any term that contains y in it must be on one side of the equation. Any term that does not must be on the other. Oh, all right, so I'm going to subtract y from both sides to get x times y minus y is equal to negative 1. And the only way to get y isolated out of all of this stuff on the left right here is to factor and make it y times the quantity x minus 1 equals negative 1. And so isolating y in this case requires us to divide both sides by x minus 1. So we get y is equal to negative 1 divided by x minus 1. So right away we know that g inverse of x, our inverse function of g, is going to be the function negative 1 divided by x minus 1. Now, if that were all that was to it, I'd be fine. But I'm going to actually add one little bit right here that was not asked in this problem. What about the domain? Well, remember that we said early on in our presentation right here that the domain and range switch for a function and its inverse. And when we switched x and y in our equation for g of x, we also changed the domain and range. So right here, what was the domain of y? Well, we were really told that the domain of g of x was the set of all real numbers except x equal to 0. We were actually told this in the function, right, when I set it up. So that means for my inverse function, the range for inverse g of x would be the set of all y values such that y is not equal to 0. But wait, there's more, because if I know that the domain of my inverse function, if I know what that is, and in this case my domain is the set of all x such that x is not equal to positive 1, then lo and behold, I know the range of my original function, which is the set of all y values such that y is not equal to 1. And so in addition to finding a method for finding an inverse function, we've actually found a new method for finding the range of the original function without having to draw the graph. Right? The way that we do it is, if we want to find the range of a given function, we find the domain of its inverse. Let me write that out. To find the range of a given function, hopefully a one-to-one function, find the range of a given function, find the domain of its inverse. There we go. So another great method, all for the price of one. Okay, more to come in the next video.